Picture this. You're sitting in the exam hall. The clock is ticking down, the tension is high, and you flip the page to a massive, high-mark question on your Cambridge Computer Science past paper. Let's say it's a classic scenario, asking you to evaluate the implementation of a wireless versus a wired network for a brand new corporate campus. Whether you were tackling syllabus 9618 or building your foundations in 0417, 0478, 0983, 0984, or 2210, this is the ultimate test of your networking knowledge. But here is the problem. Let's look at two totally typical students taking this exam right now. We'll call them Alex and Sam. Alex panics. Alex overloads the answer with raw, unfiltered computer science facts. We're talking a complete brain dump of every single 802.11 standard, memorized bandwidth speeds, and radio frequencies. But guess what? Alex provides zero actual analysis of the specific campus environment. It's just a wall of textbook definitions. Then, on the other side of the room, we have Sam. Sam rushes. Sam sees the word network and immediately starts writing a frantic paragraph about how wired is faster and wireless is portable, completely missing the nuanced command word requirements hidden in the prompt. If we take a red pen to both of these answers, they are bleeding marks. Neither of these approaches gets the grade it truly deserves. So today, we are going to fix that. We are going to decode the exact strategy to build bulletproof arguments with stress-tested evidence and absolute quality control.
To truly understand why this topic demands your absolute, undivided focus, you have to look at the numbers. The wireless versus wired networks topic accounts for approximately 15% of your total marks in Paper 2. Just let that sink in for a second. 15%. In the world of Cambridge grading, 15% is massive. It is literally the difference between an A star and a solid B. When candidates lose marks here, it's very rarely because they don't know what Wi-Fi is or because they've never heard of an Ethernet cable. It's almost always because they lack the highly specific, examiner-approved strategy required to actually present that knowledge on paper. You absolutely cannot afford to throw away these points on poorly structured, rambling answers. You need a reliable system, a system that seamlessly translates your raw technical understanding of network topologies and transmission media into maximum points every single time.
So, here is our game plan for mastering this. First, we are going to uncover the core principles of networking. Second, we'll map out the exact technical methodology you need to use. Third, we'll run through an interactive workshop to develop your evaluative thinking skills. And finally, we will expose the crucial examiner warnings you need to know to protect your grade. Okay, kicking things off with Section 1, Core Network Principles. This is where we lay the foundation. Examiners expect you to know these concepts inside and out. But before we just start listing off network topologies, we have to talk about how you actually structure this knowledge. The real secret lies in pairing your deep technical depth with the PEAL framework. That stands for point, evidence, explanation, and link. When a Cambridge command word asks you to evaluate or analyze, top-tier responses never just dump facts. They make a clear point, they back it up with specific evidence, they explain the impact, and they link it all back to the context. Now, before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
When we look at the assessment objectives for this topic, it's absolutely crucial to realize that they are not just about rote memorization. The exam board targets exactly 3 distinct cognitive domains. Every single part of your extended answer must hit one of these domains perfectly. Why exactly 3? Well, because the Cambridge marking scheme is ruthlessly systematic. It operates like an algorithm, and your answers need to be just as precisely structured to capture every single mark available on that page.
These 3 cognitive domains require you to demonstrate knowledge and understanding, practical application, and deep analysis of network systems. Let's think back to our 2 students, Alex and Sam. Alex might be incredible at knowledge and understanding. Alex can easily explain that fiber optic cables use pulses of light to transmit data and are completely immune to electromagnetic interference. Fantastic, right? But Alex might score a total 0 on application if the question was actually about setting up a small temporary outdoor festival where pulling fragile fiber optic cables is completely impractical. Sam, on the other hand, might try to apply the context but fail entirely at analysis because Sam doesn't weigh the complex trade-offs of signal degradation versus installation speed. To master these objectives, you have to decode the command words. Describe requires knowledge. Apply requires you to use the specific context. And evaluate demands all 3 domains working together, culminating in a highly justified conclusion based on hard evidence.
If you dig into the principal examiner reports, they highlight a massive, crucial secret. Candidates who showcase transferable conceptual understanding and explicitly reference cross-topic connections achieve significantly higher marks. Listen, wireless versus wired networks does not exist in a vacuum. If you're comparing network types, a truly top-tier candidate will seamlessly weave in concepts from completely different parts of the syllabus. For instance, you might discuss how the transmission medium, like the open, vulnerable airwaves of a wireless network, absolutely necessitates stronger encryption algorithms, which links directly back to your data security modules. Or you might explain how interpreting complex binary representations changes depending on the noise and packet loss typical of a wireless connection versus a stable, wired local area network. Making these cross-topic connections proves to the examiner that you understand the entire computer science ecosystem, not just isolated chapters.
Let's move right along to Section 2, the technical methodology. This is where the transformation really happens. We need to focus on what examiners call the method mark strategy, where the actual process of solving the problem earns you points. In many Cambridge computer science questions, especially those requiring calculations or step-by-step logic to determine the best network infrastructure, the final answer isn't the only thing that matters. If you can show a flawless step-by-step analytical process, you secure major points even if your final conclusion is slightly off.
When tackling these heavy network questions, you have to follow a highly standardized sequence. Deconstruct the question, extract the relevant data, select your analytical framework, execute with clear notation, and present using correct terminology. Let's actually walk through a live rewrite of Sam's rushed answer to show you how a top student applies this. First, they deconstruct the command word, compare. Next, they extract the data. Let's say the prompt is about installing a network in a heritage building with incredibly thick stone walls. Third, they select their framework, our trusty Peel method. Fourth, they execute their notation, maybe jotting down some quick notes on bandwidth limitations. Finally, they present using perfect terminology. So instead of writing something super casual like Wi-Fi will be bad because of the walls, they write a masterpiece. The thick stone walls of the heritage building will cause significant attenuation of the wireless radio signals, drastically reducing effective bandwidth, thus making a wired backbone necessary for critical infrastructure. That level of precision, that's exactly what transforms red pen marks into green check marks.
Another fantastic way to visualize the systematic processing is to identify key elements, apply relevant principles, execute analysis with clear working, verify your results, and present them in the appropriate format. This is vital when you are asked to evaluate algorithms for network routing or when you have to calculate transmission times across different media. You must execute your analysis with step-by-step decomposition. Show the examiner your data structure selection. Detail your logical implementation. If you, like our friend Alex, just jump straight to the final textbook solution without showing the working, the examiner literally has no way to award you those precious method marks. Documenting your process is absolutely non-negotiable. Now stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, let's transition into Section 3, Evaluative Thinking Skills. This is where we dive into an interactive workshop. Evaluative thinking explores the cognitive leaps that separate the top-scoring A-star candidates from the rest of the pack. You have to be able to look at complex computer science constraints, instantly spot the anomalies, identify the fatal flaws in arguments, and write technically sound evaluations. So let's put this into practice right now. Get ready.
Top-scoring candidates demonstrate critical analysis by considering multiple solutions, analyzing the complex trade-offs of wired versus wireless, acknowledging network limitations, and always justifying their decisions with evidence. Okay, let's jump into Challenge 1, the data scan. Imagine a complex data table on your exam paper comparing the latency, setup cost, and security vulnerabilities of an 802.11 AC wireless network versus a Cat6 wired network for a brand new, highly sensitive medical facility. You have 60 seconds. When analyzing such a scenario, what is the core trend you need to extract? You have to look way past the raw numbers. An evaluative thinker notices that while the wireless setup might look much cheaper initially, the security mitigation costs required to protect highly confidential patient data over an open wireless medium will increase exponentially over time. Evaluative thinking means you don't just read the data points aloud, you synthesize them to form a justified, long-term architectural recommendation.
Furthermore, when algorithmic thinking is required in these networking contexts, your evaluation must identify time complexity, space complexity, edge cases, and their specific effect on performance. This brings us to Challenge 2, Find the Flaw. I'm going to read a flawed sample paragraph. Listen closely and try to spot the sentence that loses marks. Packet switching over the wireless network is the best solution because it sends data in small chunks, meaning no single user monopolizes the bandwidth, guaranteeing fast real-time video streaming for everyone. Did you catch it? The major flaw here is that the argument completely misses the edge cases and performance effects. It fails to acknowledge that packet switching over a highly congested wireless network can lead to severe jitter and out-of-order packets, which actually absolutely ruins real-time video streaming. Identifying that is how you secure top marks. For Challenge 3, your goal during your next study session should be to take 30 seconds and speed write one perfect Peel paragraph correcting that exact flaw.
Finally, we have arrived at Section 4, Crucial Examiner Warnings. This is the final system, the ultimate cheat sheet. We are going to look directly at the principal examiner reports to expose the absolute biggest traps that students fall into. If you want to guarantee those top marks, you need strict quality control. You need to know exactly what frustrates examiners so you can avoid doing it at all costs. The examiner reports are practically a treasure map of historical errors. They tell you exactly what thousands of students did wrong the previous year.
Examiners have identified 3 highly specific, recurring mistakes that cost students massive amounts of marks every single year. When analyzing papers from the syllabus, the senior examiners noticed a very distinct, painful pattern. It honestly does not matter how well you have memorized the textbook. If you fall into these 3 traps, your mark potential drops dramatically, almost instantly. Let's break down this timeline of disaster so you can stress test your own answers before exam day.
The timeline of these critical errors usually flows exactly like this. Mistake 1, using the wrong formula or algorithm for the context. Mistake 2, completely forgetting to check boundary conditions or edge cases. And mistake 3, providing generic, copy-pasted answers that ignore the context. Let's unpack this timeline. Mistake 1. The classic trap is calculating theoretical maximum data transfer rates without factoring in the real-world overhead and physical interference of wireless protocols. Mistake 2. Students will beautifully evaluate a network node but totally forget the boundary conditions like what actually happens to the data packets during a sudden, sharp drop in signal strength. Mistake 3. This is the fatal blow, ignoring context entirely. If the question asks about a high-security corporate banking environment, and you write a paragraph focusing on the convenience of roaming around the office with a laptop, you will lose major application marks. Your answers must be meticulously tailored to the exact environment described in the prompt.
When you compare generic answers to context-specific ones, the contrast is stark. Examiners absolutely do not want generic textbook definitions. They want answers meticulously tied to the specific network context provided. A generic textbook answer might simply state that wired networks are more secure because they require physical access to a port. Okay, true, but boring. A context-specific application takes it so much further. They write, in the context of the hospital's central patient database, a hardwired Cat6 network provides superior security as it completely mitigates the risk of external packet sniffing from the hospital parking lot, which is a significant documented vulnerability of 802.11 wireless transmission. Do you see the difference there? That is context-specific application in action. That is how you dominate the exam. Let this ultimate examiner alert sink deeply into your brain. Candidates consistently confuse key terminology, so you must always define your terms before using them in your extended responses. Computer science is an incredibly, ruthlessly precise subject. If you casually use the word bandwidth when you actually mean throughput, the examiner will note the technical inaccuracy immediately. If you say a network is laggy, instead of professionally discussing latency and propagation delay, you completely fail to demonstrate academic rigor. Always utilize the correct technical term clearly, define it briefly if needed, and then use it consistently throughout your response. This simple quality control step proves to the examiner that you truly understand the underlying theoretical architecture of what you are talking about. So, the ultimate question for you today is whether you will change your strategy right now and start focusing on the exact methodology that examiners actually reward. Will you be like Alex and Sam, relying on rote memorization and rushing? Or will you apply this structured, deconstruct, solve, evaluate methodology? There are 3 rules that guarantee top marks: command word decoding, Peel framework application, and strict time management. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams, at @AceTheExams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @AceTheExams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the exams. Your Cambridge success starts here.
While the digital platforms we interact with every single day feel like magic, remember that the underlying infrastructure powering them relies entirely on the very wired and wireless concepts we have just evaluated together. Mastering these frameworks doesn't just get you a grade. It ensures you have a deep, structural understanding of how our incredibly connected world actually operates. But beyond any exam room, as global networks continue to rapidly evolve, blending heavy, high-speed wired backbones with highly dynamic roaming wireless edge devices, contextual evaluation becomes even more critical for future engineers. So the next time you stream a high-definition video or connect your phone to a public Wi-Fi network, ask yourself, what hidden, complex structural trade-offs were made by network engineers just to keep you connected today? Keep analyzing, keep evaluating, and I'll see you in the next one.